Hey everybody, I wanted to give an illustration of what's happening during crystallization. We've been looking at phase diagrams, and during cooling, first one kind of mineral will form and then another kind of mineral will form. And we see this in Bowen's discontinuous and continuous reaction series. So why does this happen? And the reason why is that because some elements are incompatible. By incompatible, we mean that we have an element that does not go into any of the crystalline phases. So an incompatible element is one that is rejected by the crystals that exist in some system. So that's our definition of an incompatible element. So here, I'm going to take water as our incompatible. It's not so much an element, but a molecule. But most minerals don't absorb water. Some do, like amphibole or biotite. But let's say we have olivine. Now, if we have a batch of magma that's shown here in orange, and let's say we have 10 water molecules, and we let the system cool so that we make a little bit of olivine, let that olivine be green and form at the bottom of the chamber. So here are olivine crystals that just take up that whole green space. Notice that the water molecules, since they're not being absorbed into the olivine structure, are crowded into this smaller amount of magma that's left. And if we crystallize a little bit more, then the concentration of water is even higher. And then if we crystallize further, concentration is higher, and we can continue this process until the water is highly concentrated. If you imagine this to be a volcanic system, at a certain point, if these water molecules are so highly concentrated, then the system becomes saturated in water, and instead of the water molecules being dissolved in the magma, they're starting to form bubbles, and those bubbles can change the behavior of the system. Those bubbles have a very low density, so they could exert greater magma pressure in a chamber that's sitting in the crust and maybe contribute to an eruption. These don't have to be water molecules, though. Coming back to the original diagram, I called them water, but they could be something else. This could be, let's say, potassium oxide. And as we crystallize the magma, we get a higher and higher concentration of potassium element, the element potassium or potassium oxide, where it becomes so highly concentrated that the liquid makes potassium feldspar. So if you look at our video related to Bowen's reaction series, the reason that potassium feldspar is down at the bottom is that potassium is acting like the water molecules here. It's another example of an incompatible element, one that is not easily absorbed into the mineral that's forming, but during cooling and crystallization, it slowly gets concentrated to the point where they can start bonding to one another and making a mineral like potassium feldspar.